Hello prep 3. Now we will complete the second part of our lesson, radioactive and nuclear energy. Now we will talk about the radiation pollution. What I meant by pollution concept? Pollution means any addition to the substance. By the meaning by the addition of any substance to the water, this will cause water pollution. On the other hand, the addition of any substance to the air, this will cause air pollution. This is the same like in radiation pollution. Increasing the amount of radiation in the environment causing radiation pollution. By knowing the radiation pollution, so we must know the sources of radiation pollution. Let's see these sources. We have two sources of radiation pollution. Number one, natural source. What I meant by natural source? Natural source means the radiation that emits from radioactive element that already found in nature. So this source is called natural source. The second example of natural source, the radiation that comes from the outer space. We have many radiation comes from the outer space. These radiation called, one of them is called cosmic radiation, and this is considered as one of the sources of radiation pollution. The radioactive elements that are found in nature and produce natural radiation such as rubidium and selenium. Okay, this is the first kind of sources of radiation pollution. Natural source. Number two, artificial sources. Number two, artificial sources. Artificial sources means the radiation that emits from radioactive elements that is made by the human. So these sources called artificial sources, such as the radiation that comes from nuclear reaction or nuclear bombs, or such as the radiation comes from nuclear reactors. Now, who can tell me the answer of this question? There are two sources of radiation pollution, which are space and space. Try to think. Yeah, exactly. Natural sources and artificial sources. Now, we must know the effect of radiation pollution on the human body. Let's see this effect. The radiation effect on human body. A. Effective exposure to a large dose of radiation for a short time. Pay attention. Large dose, short time. The effect of exposure to large dose of radiation for a short time. Number one, damage spleen, like in this figure. What I meant by spleen? Spleen is an organ inside your body that may be damaged if it's exposed to a large dose of radiation for a short time. Number 2, damage of the digestive system, like in this. Damage of the digestive system, like in this picture. The radiation may be damaged the digestive system, such as it may be cause stomach ache. This is the stomach, and may be caused stomach cancer. Okay, and the small intestine, large intestine may be damaged from the radiation also, such as intestine cancer. Number 3, damage nervous system. The radiation may damage the nervous system, such as the radiation comes from the mobile phone. It may damage your brain, then it may damage your nervous system. Okay. Number 4, damage bone marrow. Bone marrow is a structure inside your body responsible for formation of red blood cells. The damage of bone marrow leads to decreasing in number of red blood cells in the human body. You can see the difference between the number of red blood cells in this picture. Here you can see the normal number of red blood cells, and here the number of red blood cells decrease. Number B, effect of exposure to a small dose of radiation for long time, such as months or years. Pay attention. Small dose for a long time. Number 1, physical effect. We knew that physical concept related to the change in the external shape. So the physical effect or changes appears on living organisms after exposure to the radiation and causes skin cancer, like in this picture. Number 2, genetic effect. Genetic effects accompanied by the structure or a composition of chromosome. Do you remember the composition of chromosome from the first term? Any change in the 6 chromosome composition results abnormal birth, like this in the figure. Number 1, physical effects that cause skin cancer. Number 2, genetic effects that cause sex chromosome composition changing, producing abnormal birth. Number 3, cellular effects. From its name, cellular effects accompanied with the change in the cell composition. The change in the cell composition leads to destroying the cell. If the chemical composition of the hemoglobin changes, it becomes incapable of carrying oxygen. Hemoglobin cells incapable of carrying oxygen means they can't carry oxygen. Can you imagine your body without oxygen? Sure no, we can't imagine it. Now, listen carefully for this note. Very important note. The international unit of measuring the radiation is sieverts. What is the measuring unit of radiation? The measuring unit of radiation is sieverts, yes. Very important note. So please pay attention. The safe dose of radiation for those people who work in radiation field shouldn't exceed 20 millisieverts, pay attention, per year. 20 millisieverts per year. Okay? However, the safe dose of radiation for public shouldn't exceed 1 millisievert per year. About 20 millisievert per year for people who work in radiation field and 1 millisievert per year for public people. Who can tell me why the people who work in radiation field can expose to 20 millisievert per year, but on the other hand, the public shouldn't exceed 1 millisievert per year? Are they superhero? For sure no. But they're wearing gloves and protective cloth to protect against radiation, like in this picture. Now let's see how can we protect ourselves from radiation pollution. Number 1, don't be exposed to nuclear radiation that greater than safe doses, which are 20 millisieverts per year for people who work in nuclear reactor and 1 millisieverts per year for the public people. Number 2, workers with radiation element in labs should wear radiation protective gloves and masks, like in this picture. This is the protective gloves and protective masks. Number 3, follow precautions with radioactive wastes away from underground water path, earthquakes, volcanoes, and animals. So we must get rid of radioactive wastes away from each of the following: the water path, earthquakes, volcanoes. Number 4, the nuclear wastes of weak and medium radiation. Pay attention, weak and medium radiation only, must surround by cement layer and placed in the ground. Before we get rid of weak and medium radiation wastes, they must surround by cement layer and placed in the ground, such as in this picture. In this picture, we collect the wastes of weak and medium radiation and surround them by cement layer, then place them in the ground. Okay? While strong radiation, what happens to the strong radiation? Strong radiation must be cooled by water firstly. If strong radiation must be cooled by water firstly, then place them in deeply hardened ground away from inhabited area. Inhabited area means the area that includes people. Number 5, building lamps for nuclear plants to cool the hot water before throwing in seas and lakes. So we must build places for cooling the hot water that produced from nuclear reactors. What is the hot water? The hot water produced from nuclear reactors before throwing in seas and lakes. Pay attention. Plants here means factories. Nuclear plants means nuclear factories or nuclear reactors, not the plants in the soil. Okay? Okay. Now, who can answer this question? Some nuclear plants make artificial lakes for themselves. Who can tell me? Some nuclear plants make artificial lakes for themselves. Yeah, exactly. Excellent. To throw their nuclear wastes in them. Now, please listen carefully to the last concept in this lesson. Isotopes. What is meant by isotopes? Isotopes considered as some elements. They have the same number of protons, but they have different number of neutrons. Again, some elements have the same number of protons and different number of neutrons. Okay, so what are they meant by isotopes? They are elements that have the same number of protons and different number of neutrons. For example, the hydrogen element. the hydrogen has atomic number is 1 and its mass number is 1. There are isotopes of hydrogen elements that have different number in mass number. This is the other example. It has 1 electron in atomic number but 2 in mass number. And the third one, hydrogen, its atomic number is 1 and its mass number is 3. In the first case, the number of neutrons equal the mass number minus atomic number. So the number of neutrons here equal 0. Okay. In the second case, the number of neutrons equal the mass number minus atomic number equal 1. In the third case, the number of neutrons equal the mass number minus atomic number equal 2. Now we can observe that these elements have the same number of protons. This is number 1. Okay. The same number of protons. This is number 1. And here 1. And here 1. But they have the different number of neutrons. In the first element equals 0, second element equal 1, third element equal 2. So now we can understand what is meant by isotopes. They are elements that have the same number of protons but different number of neutrons. Okay guys, now I need from everybody to search about the explosion occurred in Russian reactor at Chernobyl. So please search about this title and I will discuss it with you later. Thank you and goodbye. See you later.